Welcome again. We've got 4 startups now in the field of Industry 4.0. That's what it's actually called. I think it gets a little bit further than that. And first of all, I'd like to welcome on stage idatase, however you pronounce it. Welcome, and stage is yours. You have 2 minutes now to actually present your company and tell us a little bit about idatase.
Okay, thank you, Claes. So hi, everybody. I'm Tung Dang from idatase. We are a pretty young startup from Frankfurt. And we come here with the idea to have the people understand the Internet of Things. So we all know about Internet of Things is all about connected devices. So we have a lot of devices, they are connected together, and we have a lot of things to do with them. But there is one thing that every company and every person have to do with those devices, that they have to maintain the system. So what we're going to do when the problem comes to our system? So our idea is that we try to have the administrator or the person who are in charge of maintaining the system to understand the situation of the system. So for example, if you have a network of computers, when the problem comes, you will need to look at every computer to see what happened with this one and what affection it has to the network. So we try to collect the data from every computer or every device inside this network. We will get the pattern from that. So the next time, if the problem comes again, we try to compare the situation, and we will say that it happens before. And you will know that where and when it happens. So we are currently working on developing this product right now. And the first thing I want to say with class is that you shouldn't quit now, because at this right of this problem, to maintain this kind of system, we need amazingly skilled chief data scientists, because we have to deal with terabytes of data in order to understand the system.
Okay. You have another 11 seconds or 10. Is it okay? Is it okay?
It's okay.
For you? It's okay for you. So thanks that you need me. That's perfect. Really perfect.
As always.
We have a few minutes to actually talk a little bit about it. Can you tell us a little bit more about how you actually tag now all these network data? So how do you actually get it out? So I saw some of these Bluetooth devices you actually have at your booth. Can you tell us a little bit more? So how can I get the data out of these infrastructures and these networks?
Yeah, of course. You know already that sensors, they have to send the data somehow. It would be the logs data. It would be the sensor data, for example, temperature, humidity, or something like, I don't know, a distance or their signal. So our idea is just that if we use this data in another way, not to create something fancy, but to understand the system based on this data. So it's just like, for example, with your example about the description of picture. So you have a picture, and then you have a text description from that picture. So we try to create a picture from those kind of sensor data. And if we could get the description of the situation based on this data,
okay,
then.
And you also talked about that your solution is capable of identifying patterns from the past and predict it, or let's say find it again now or in the future, sort of. So can you tell us a little bit, how does the training of these kind of models work, and who is doing the interpretation? So who is saying on the past data, well, this is a kind of interesting pattern for whatever kind of way, but this is interesting, this and this, that I really want to find it again in the future. So who is doing it?
Yeah, it's kind of learning process. So basically, you will have the administrator for that. So every time problem comes, these people, they will press the button, for example, and tell that, OK, there is a problem. And it happens from that computer, because it is training data. And then we use the most innovative deep learning algorithm to use this data, like the features. And then we try to get the pattern from that. just like you drive many pictures into your training data, and in order to get the face recognition algorithm from that.
Okay, but in the end, there's a human saying, okay, this kind of pattern that the algorithms detected means whatever.
Like that, yeah.
Okay. Well, thanks, first of all.
You're welcome.
So have a seat over there, wherever you, or here, wherever you prefer. Next is IS Predict, I think from Germany as well. So welcome on stage. Is your mic working?
I can test it. Yes, it's
all
on.
right. So you have 2 minutes. The stage is yours.
2 minutes. My name is Britta, and I would like to follow up on your excellent presentation you gave, where you said big data is data availability, it's data analytics, it's new business models. And that is exactly where we are focusing on data analytics. We have developed a software solution for predictive analytics, predictive control. Now you might say, all right, there are plenty of other tools available, either here in the hall or even SAP, big company offers such a thing. However, we as a young company, we work together with Siemens, for example. Why do they do this? Because we can solve problems and give answers in areas where processes are very complex, data is very complex with a lot of influencing factors, and now we can give answers with other tools established tools cannot give. As I mentioned, Siemens predictive maintenance, for example, with EMBW, a large German utility, we work on complex energy forecasting. With BASF, a large chemical company, we work on complex logistics planning, so it's always where it's very complex. How can we do this? Well, we have a special, and you talked about it as well, a special self-learning algorithm. The system can learn, can find patterns, can recognize, and in this way it is able really to filter what is really relevant in order to give answers. And I mean, even big SAP is asking us to come to their clients to talk about, in industry, to talk about predictive quality control, which means in order to reduce the loss products, the products which do not have the right quality, and to steer the machinery in a predictive way. And one thing I want to mention, who of you knows Gartner Research, Gartner from US? A few, okay. They were also interested in what we are doing. And then we said, all right, what I told you about predictive analytics, predictive control in complex processes, and then finding very good answers due to self-learning. And they said, you know what, if self-learning really works, that's democratization of analytics, which means that not only, as you mentioned, data scientists will find the solution, and I mean, it's our colleagues as well, but actually in the end, everybody of you, like you use Excel nowadays, in the end you could use predictive analytics tools and they would give the answers. Now my time is over, I see.
Yes, true. Perfect. Thanks. I think I want to dig into this self-learning again, because of course it's really difficult to just push any kind of data into any kind of, let's say, smart or in what kind of algorithms and get the results out you actually need or want or that meet your client's needs. So self-learning, I think it's not meant in the broader sense, but more in a, let's say, okay, you train it on one kind of solution or one kind of question, one kind of set of requirements, and you can transfer it to, let's say, similar kind of requirement set without retraining. Is that true? And how does it really work?
Yeah, that is true. I mean, of course, we first need to learn, as everybody, on data which is existing for that question, which solves that question. And then that is where the data scientist for sure needs to be in. So we need that expertise. You show some very nice slides with formulas and everything. But then what our system can do, and I mean, colleagues have spent a lot of time to get this done, then it adapts automatically, and even if there are a lot of influencing factors. Let me give you one example. One of our clients, a steel company, they have ovens which require a lot of energy, and they had a problem for their energy dispatching to understand how much energy will those huge consumers of energy actually need, because they need to do the dispatching. And the problem is, even if they know what goes into this oven, it's zigzag consumption. So they really can't say how much it is. So we did the, again, complex process. We did the forecasting there in a very high accuracy. And then they said, all right, now oven number 1 is fine. We can do the planning and dispatching. But we have a problem, and we knew about it. It's oven number 2 and oven number 3. And then it was October when we did this, the testing system for oven number 1. And then they asked us, well, when should we plan the IT testing for over number 2. When will you be ready? Now it's October, there will be Christmas. Do you think we should do that in February? And my colleague said, why February? It's a self-learning system. Yeah, you know, you can throw away your models, because Oven 2 is completely different. It's 15 years older. It has a completely different process. One is with compressed air, one is without compressed air. And the colleague said, no, please give me the data, the same data you gave me for Oven 1. In the morning, he inputted that data into the system, and the system needed to learn. So it was like half a day, 4 hours learning, learning, learning. But the data scientist colleague was drinking coffee in the meantime, not doing anything. And in the afternoon, accuracy for forecasting was for Oven 2, was available. And the same happened with Oven 3. So not 3 or 4 months of creating models again. And that is what we mean with self-learning.
OK. Thank you.
You're welcome.
Take your seat. I think we have lots of other questions, but we don't have the time. So we have to stop here first. Now, please welcome on stage Looped. That's you. Perfect. You're 2 minutes on stage. Please join us and present us Looped.
All right. Great to talk to everybody. Basically, we're from Looped, and we make wearable devices for business applications. Now, you might be wondering, what kind of wearable devices would businesses need? Well, this conference would actually be a perfect example. Right now, I'm actually wearing one of our beacon badges. And this is a mesh beacon that actually allows you to exchange contact information with other people by tapping the badges together. Now, isn't that an elegant solution for the traditional business card? And we also allow you to get electronic material from tapping the booths. And most importantly, we let organizers track all of the attendee engagement or all of the interaction between all of the different attendees so that I know, are the right people meeting each other? Are they going to the right speaker sessions? Or is everybody here getting relevant information that they need in order to further their career? So basically, we're a hardware, software, kind of like IoT, wearable, big data company, all mixed into one bag. And what we provide is a total solution for museums, theme parks, conferences, trade shows, and for these people to get as much information, because at the end of the day, these events are huge investments, and you want to know whether these events are actually being useful or are they useful or not. So we're powered by very powerful big data analytics, which parses all of this data into useful information for the organizers at the end of the day. And so we just closed our seed round. Our investors include Mark Benioff from Salesforce.com, Tim Draper from DFJ Ventures, and some other notable investors as well. And we're a company based in San Francisco. So if you have any questions for me during or after this presentation, please let me know. Thank you.
Perfect. 2 minutes. Thank you very much. And can you give us a little bit more insights into this data flow? So where does the data from the badge go? Does it go to an app first and then to a backend solution where it gets analyzed? So how is the data flow of your solution?
Yeah, great question. So basically, all of these beacons, or any beacons that you know, are constantly emitting data. And when you have 40, 50,000 people all in a trade show event, this information gets this gets big very, very quickly, very fast. So basically what we do is we have hubs or sniffers that constantly pull this information, pull it into our database. And as this database is very huge, we have to have an engine, a big data engine that actually parses through all of this information and presents it in a user-usable format at the end. And so these beacons themselves, they're also very interesting because not only are they traditional beacons, but we're taking beacons to the next level. These beacons can actually talk to one another as well. And that's actually what enables the data exchange between each other.
OK, not sure if you know it, but the Germans are very sensitive when it comes to their data. So how do you deal with these data security, data privacy issues, especially when you want to enter the German market?
So the German market is one we're very keen to look into, because once you conquer Germany, you conquer the world in terms of privacy.
Thank you. I don't know if it's true, but...
But OK, so the two main markets that we're working on is California, most obviously, has very, very strict privacy rules. And Germany also has very strict privacy rules as well. And one of the ways that we're going about that situation is the fact that all of the information that you provide is completely opt-in. You have total control over what kind of information you want to provide, who do you want to provide it to. And at the end of the day, if you don't want to participate and it doesn't provide much value to you as an attendee, then you don't have to do it.
OK.
Yep.
Thanks.
Yep.
Take your seat. Last but not least, we have waylay.io. So welcome on stage.
Thank you.
And your 2-minute pitch starts now. Thanks.
OK. Hello, everybody. My name is Piet van Dalen. I'm from Waylay. And when we founded Waylay about a year ago, we were looking at machine-to-machine solutions. And we were thinking, hey, these systems are typically quite closed, are not very interoperable. And at the same time, they are difficult to evolve and adapt over time because they are typically built for a particular use case. So when we thought, would it not be nice if these systems would be more open, more modular, being extendable and being more API-driven, like many of the technologies being used in the internet today and in the API economy. And that's basically the idea behind Waylay. So Waylay is a business rules engine that has all these properties, and basically it allows you to combine data from devices, from applications and online services. And it allows you to combine those data and to build logic on top of that. And based on the outcome of that logic, you can take actions. And actions can be as simple as sending alerts, like SMSs or email. It can be writing something into a database or a ticketing system, or taking actions back on physical devices, like changing parameters. So Waylay can be used for monitoring applications. It can be used for automation and also for predictive maintenance. So it's a horizontal platform that can be used in multiple verticals. But today, we're very active in smart buildings, predictive maintenance of remote machinery. But we also have activities in traffic management, as well as beacon-based applications. And our customers are either vertical IoT solution providers or horizontal IoT platform providers or integrators. And they use Waylay as a kind of middleware component, which is embedded in an overall solution and which is typically invisible for the end customer. And we offer our service as a PaaS model available on the internet, starting on a monthly subscription basis as of €149 per month. Thank you.
All right, thanks, perfect. It sounds a little bit like Yahoo Pipes or if this, then that for the smart business world. So definitely interesting.
It's a very good summary. We're like, we position ourselves as the if this then that for B2B.
Oh, yeah.
We're exclusively B2B. And we see like 3 main differences between if this then that. First one is both on the input channel and the output channel is completely modular. So as a developer, we focus on developers. You can basically connect whatever you want. So you're not constrained to a fixed set of inputs or outputs. Secondly, the logic you can build is somewhat more complex and advanced than if this then that. And thirdly, your platform is completely API-driven. So as a user of your platform, you can build your own user interface on top.
And you talked about open interfaces for data input-output. So you can build your own, let's say, data input queues and data output queues. Can you also extend the core by some sort of open API or dev SDK that you can extend the possibilities, for example, in special analytics for some sort of vertical? Is that part of your solution, or is it just what's in there you can get?
So the openness is both on the input side and the output side, where you can basically attach or send data to whatever you want. The platform is completely API exposed, which means everything you can do within the platform, you can also do over the API. And the logic we can support today is pretty powerful. So if customers come up with new use cases for which we don't yet have support, we're eager to enhance our platform. But so far, feedback has been really great.
Last one, but the really short answer, please. Is it only cloud-based, or can I host the system on-premise? Because when I talk about enterprise, they want to have it normally in-house. Is it doable?
It's the main model is cloud-based, but for bigger opportunities, we're also looking into on-site deployments.
All right. Yeah. Thanks. Have your seat. I think before I start with the discussion, we have 7 minutes, so it's not that long anyway. But I just want to make it a short, open round. Does anyone have a question to one of our startups? Otherwise, the time's over, and I talk all the time, and it's your chance now. No? All right. They are around. What's your booth number?
15.
15? It's somewhere? Where is it?
Over there to the left.
Okay, 15. What's your booth number?
34.
34. Okay, write it down. And yours?
It's 20. It's over there, and you see the red table like my scarf.
Yes. Okay, pin that down, and yours
We are
is
19.
It's next to
Exactly.
those. Okay. I talked a lot about. I don't know if you saw my talk. It doesn't matter anyway. I talked about the IoT ecosystems or IoT in general, and the question is, from your point of view, what is needed or what's missing right now in all these Internet of Things, let's say movements, standardizations? We have a lot of these IoT standardization bodies coming up. So what's missing right now? What do you need to actually generate more business or place your product or make it better or more integrated in a smart whatever context? Do you want to start maybe?
Yeah. Well, I think not so much in terms of standards, but in our opinion, the IoT world will evolve to adopt many of the principles that are today common in the internet. So it's not about one company owning the space. It's like being something modular and API driven, where you can dynamically compose services based on combining products from different companies in an API driven manner. There are still some machine-to-machine companies out there that think as a single company you will own the space, and that are like closed ecosystem. I believe more in open ecosystems.
I think we had that 20 years ago or 15 with the SOAP web service interfaces and all that. So it's not new, but it didn't get off the ground really. So maybe from your point of view, from the US maybe, so what's missing maybe? And
I think there's a great vision for IoT, the fact that everything is internet connected, but we can only go so far as the technology allows us. And so what I mean by that is there's a lot of grand schemes, a lot of dreams, but at the end of the day, it's how reliable your Wi-Fi infrastructure is. It's how long your battery can last. It's how far your Bluetooth low energy signals can get out there. And actually, I do feel like Bluetooth low energy is one of the first standards that's kind of driving the force behind IoT. Because if you look at companies like Locatron or other companies, they're having to rely on Bluetooth low energy and Bluetooth low energy only because right now the standards such as Wi-Fi, they're not low energy enough to support this kind of IoT infrastructure. So at the end of the day, I feel like we can dream all we want, but we need to have the technology behind it to actually power it. And I feel like the technology just isn't there advancing as fast as how fast we want it to be.
Okay, interesting, interesting. How about data in this kind of way? So if I'd say, I could say, well, Internet of Things is just some sort of, let's say, okay, we use big data now and put it into some sort of nice and fancy products. Is it true?
Well, maybe part of it is true, but I think really it creates new business models. I mean, when you think of machinery, of companies who produce machinery, now they are changing their business model, and it's more the services where they save more money. Or think of Germany utilities, whether it's E.ON or EnBW, they are just yesterday or a couple of days ago, they have announced they are losing a lot of money. It's also because of the energy vendor and everything, but they need new business models. They require more and more data scientists. So I believe in this Internet of Things, whether it's now in energy area, whether it's in production, we don't know yet what will all happen. I mean, if you think of 10 years ago, how many apps would you have dreamed of your mobile phone? Now it's so many. Nobody could have imagined.
Which you don't use normally.
Well, you use some.
Well, I don't.
But they are important. At least the weather probably you have a look at now and then. Yeah, but what I want to say is there are still a lot of possibilities, or the vision is huge. But I think we need to get it done. Technology needs to go step by step. And then really, what I think as well, the large companies really need to invest in it and do it. Because if they don't do it, it's like a Gartner hype cycle, and it will be gone. Okay. It will just be old wine in new tubes.
Yeah. A last one for you.
Yep.
In Germany and maybe in a lot of other countries as well, we of course don't talk only about Internet of Things, but about Industry 4.0. Do you feel that Industry 4.0 is something that really gets off the ground now? Does it help you? As you are really into it right now with your products, does it help? Or is it just a word?
I just want to say that Internet of Things and Industry 4.0 is not that major. It's not what we want at this moment because there are a lot of things we need to understand the sensor, the machines, where we want to apply the data, the big data technology. But the first thing we want to do is we need to understand those kind of machines. So it's that every company, they want to apply IoT. They create a new one. They create a new standard. And it's pretty difficult for new people to join into this industry. But it is pretty interesting. And I think it's promising for the next 10 years, I guess.
All right.
Yeah.
So I'd say thanks. Closing round, I think we need to learn. That's what you said. That's good. We need to learn about machines. Great. We need to understand. That's what I think it perfectly fits you. You said it's hard work, and I totally agree. It's not just plug it together and it works. It's hard work. And it's good if you open it up and create these interconnections and open it up to the input side, to the output side. So learn, understand, hard work, and open it up. I think that's the perfect fit for what we want to talk about here. So thank you very much. 40 seconds left, but doesn't matter. Thank you.
Thank you, Klaus.
All the best with your startup. You too.
Thank you very much.
You too, and all the other 46 ones as well, of course. And thanks.
Thank you.
Okay, thank you.
Give them a warm applause. Thanks a lot to our 4 startups and, of course, to the charming host, Klaus Bollhofer.